Hello everyone. So let's do the SMDM part 2. For that, think I'm connected. Yeah. So I have done till the hypothesis testing for single populations, right? So now it's for multiple. Multiple is basically same concept, but just the formulas are different for the Z statistics, T statistics, and then for population also it's a bit different. This one for uh, con- con- confidence confidence interval, and this is for the hypothesis. Just put these values in place of the other values and you will get it. ANOVA, only this table value you have to calculate. So if k number of samples are given, degree of freedom is k minus 1. This is total number of samples minus k, and SS, this addition of SS between plus SS within is SS total. MS between is SS between by k minus 1. MS within is SS within by nt minus k. And F statistic is MS between by MS within. And p value is F dot dist 1 minus F dot dist of this F value. And degrees of freedom, you have to put these two degrees of freedom. And G square, I think, chi square, I think I'll solve one problem. So let's do it one by one. So in this hypothesis, this is the first problem we have. A consumer product testing organization uses a survey. Um, Let me read it once. Yeah, so this is the problem of the first variance where the population standard deviation is given. Okay, so here it is said that two x1 bar and x2 bar are given, and the hypothesis testing is for they are same or not, and the alternative is they are not equals to 0. Now for this scenario, we have to conduct the hypothesis test with the population standard deviation 15 for the both cases. Okay, so what we have to do is just calculate the Z statistics and then calculate its p-value. This is the formula. Let's create a sheet. X1 bar equals to, it's given 89, 88, 89, 88, N1 280, N2 300, standard deviation 15 for both. Okay, now the formula is x1 minus x1 bar minus x2 bar by now d is 0 because we have to calculate if the difference between it is 0. Okay, now if it was given another thing, you have to just put it in the formula. It's x1 bar minus x2 bar minus d0, which is 0 for this case. So z stat is 89 minus 88 by root over sigma 1 square by n1 plus sigma 2 square by into add the whole thing and it's root. So this is the Z statistics value and now it is a two-tailed test. So for two-tailed, calculate the right-tailed. 1 minus num dot s dot test, comma, true. So two-tailed will be double of this into 2. And the p-value equals to sorry, this is the p-value, right? Yeah, so p-value is 4224 and z-stat is 0.80. Now the same reason for because p-value is less than alpha, alpha is maybe given somewhere 0.05. Yeah, so it's less greater than that. That's why we can reject and provide a 95% confidence interval for the difference between the population. Now for confidence interval, the equation is given this into z alpha by 2. Now z alpha by 2 is now this standard error is this value. Now the equation is into z alpha by 2 at alpha value is by 2 is 0.025 z alpha equals to norm dot inv 1 minus s. This value. So MOE will be 2 into standard error. Okay, so confidence interval will be x1 bar minus x2 bar is 1. So 1 plus this 1 minus so minus 1.44 to 3.44. Okay, this is same. Let's do the same thing. Okay, is there any sample? Okay, there is sample distribution given. So for that we have to calculate t distribution. So similarly, kind of this for t it's 1610, 6.8 to 6.29. Nine, sorry. 1610, 1610. Now we have two sigma values. And deviation 1. And those are 165.75, 65.75. Standard error can calculate by this equation. This we have to put the values, which I don't want to. It's gonna take time. Let's do this then, I guess. Let's calculate the degree of freedom first. Okay. Here also d value is 0, right? Because the hypothesis testing is 0. So, okay, makes it a little simple, but anyways. First of all, the t df is s1 square by n1 plus s2 square by n2 whole square. So dof equals to s1 square n1 plus 2 square by n2. Its whole square by 1 by n1 plus 1 into s1 square by n1 whole square. S1 square by whole square plus S2 square by, sorry, 1 by 2 plus 1 into minus 1, sorry, S2 square by n2. So looks good. The whole thing's whole square now. Yeah, let's see. Degree of freedom is, it should not be this much, this less, right? I think I messed up somewhere. 5. Okay, let's see. Then the JSTAT in case of here it will be tstat is x1 minus x2 by the whole standard error equals to, and right will be t dot test, comma 1.416, the answer 1.843 should be the answer. Okay, it's wrong. And somewhere I have messed up and I don't want to check again. Wait a minute. Okay, standard error. Standard error formula is, oh, okay, I didn't calculate standard error, did I? Standard error is n1 x2 square by n2 whole root x1 square by n whole root. It is correct. Degree of freedom. Uh, I just don't want to do it now. Okay, let me check once. Okay, I think for the standard error, it is s1 square by s n1 by s2 square. Here I have again wrote s1. So remove this and put s2 square by. So which changes the whole thing. Now tested is 18.84. I think it's correct. Yes, and p value, it is a right tail test. 0.15. No, 0.04. Okay. Just check once again. Just put the correct formulas and it will come right. And okay, 0.0414. The statistic is same. Okay, let's calculate it one by one. So it's okay. Didn't I do square? No, I did do it. Now the lower part is Okay, this is the problem. Y n1 minus 1 into f to the power 5. Not in the mood to solve this. Okay, so just do it carefully. You will get the answer. Similarly, the other things for the p value also is the same. There are formulas given, just put the values and use the same logic. It's also a big calculation. Do it carefully. I don't know. I'm not going to do it carefully. It seems. Okay, then yeah, this kind of table will be coming in the ANOVA. So if this is given, this is going to be total minus this 80 degrees of freedom. So it has given that 8 experimental units were used for each of 5 liters of the factor. Complete the ANOVA. Okay, so total 40 units were used. 8 experimental units and for each 5 levels of the factor. Okay, so mu1, mu2, dash 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 to mu k. So k value is 5. So here it will be 5 minus 1, 4 and 40 and 40 minus k, which is 5 is there 35 and the summation is 39. This is 380 by 4, this is 80 by 35, this is 95 by 2.28 and this is the p value of this f stat. Okay, and for the chi-square, I think I don't know if I want to do this. Was there any question on chi-square? Yes, I think this one is right. No, this is ANOVA. What is it? This is ANOVA. Yes, this one is like chi-square. 200 is total number. Okay, use so look out for the formula. It is observed frequency minus expected frequency whole square by expected frequency. Degrees of freedom is r minus 1, c minus 1. Okay, so here we know sum the total. From this, calculate create a expected table which you can create by multiplying this will be always fixed. Okay, I think how do it is dollar sign, sorry. This for this sorry about that. I think I paused somewhere. I forgot. Sorry, but I don't know where I stopped. I guess in the t statistics, just put the values. I am not doing the calculation whole thing. You have to just put the values carefully and calculate. And for P also similarly calculate the values by putting it in the same thing. And for ANOVA, SS between by and SS within and SS total. One of one of the things are gonna be given. Like if there are five population which are given, and in each population eight values are given. Like here K populations are given, right? And each in each, let's say K value is 5 and okay, let me show the equation. I think yeah, so here 8 experimental units were used for each of the 5 population. So 380 is given, total is given, so it will be 80. Now degrees of freedom will be how many population is there? 5, 5 minus 1, 4. And total how much samples we have? 8 into 540. So total will be 40 minus 139, and this will be the difference of both 35. Now 95 will be 380 by 4. This value will be 80 by 35, and F statistic will be 95 by 2.28, and P value will be 1 minus F dot stat, this F value, okay, with the degree of freedom 4 and 35, and you will get the P value. Now for the chi-square, what I was doing is, yeah, I was doing this formula. So just put the formulas here, sum all of the rows and all of the columns, and create the expected table, which is for this one, you have to take this into this by this. For 35, take 80 into 70 into 200. For 12, it will be 47 into 30 into 200. So equivalent. So for 10, it will be 80 into 30. Corresponding row, corresponding column. Multiply divided by the total. You will get expected. Then calculate the difference from each actual and then square them up. Then sum of the whole thing 167.51. Now the formula is by EIJ. Okay, so I think so we have to calculate the formula is difference square by EIJ. So we know the difference square by EIJ is expected one is this one. Yeah. So like that, do for all, and then sum of this 9.95. I think yeah, this one is a value and p value is chi-square. There is a formula called chi-square dot dist is the x value, degree of freedom is row value minus 1, column value minus 1 multiply. So there are 3 rows and 3 columns. So 3 minus 1 into 2, 3 minus 1, 4, comma, 2.95. So 1 minus 0.95 is 10412. Okay. So because it is given, it is right tailed, and right tailed is 1 minus. And if that is also right tailed, somewhere is given. Yeah. So that's it. Thank you.